Something unusual is happening in the constellation Orion. One of the most massive and brilliant stars visible from Earth has been acting in ways astronomers still can't fully explain. Its name is Betelgeuse, a red supergiant known for its sheer size and intensity, but recently it's been dimming, pulsing, and spinning in ways that defy expectations. And now, scientists are asking a startling question. Is Betelgeuse dancing with an invisible partner? At the heart of this mystery is a star so immense it could swallow Mercury, Venus, Earth, and Mars if placed in our solar system. Yet despite its glowing presence, something seems to be subtly influencing its behavior, perhaps something hidden, faint, and cloaked in cosmic dust. In this episode, we'll dive into the strange signs surrounding Betelgeuse and explore a growing theory that could rewrite how we understand massive stars and their final moments. Betelgeuse, perched on Orion's shoulder, has been a subject of wonder for centuries. But in recent years, it's proven to be more than just massive. It's volatile. In late 2019, astronomers worldwide were startled when Betelgeuse suddenly dimmed, significantly and unexpectedly. The drop in brightness sparked rumors of an imminent supernova, but further analysis revealed that the star had likely expelled a massive cloud of dust which temporarily obscured its light from Earth. The star didn't explode, but the event raised a more profound question. What exactly is happening inside or around Betelgeuse? The brightness of Betelgeuse isn't constant. It naturally fluctuates over time due to internal pulsations. But there's one specific rhythm that stands out, a slow, repeating pattern roughly every 6 years. This long secondary period is too regular to be written off as internal turbulence. It hints at an external source of influence, potentially the gravitational pull of a hidden companion. That theory gained credibility as astronomers speculated that Betelgeuse might be part of a binary system with a low-mass star orbiting nearby. If real, this companion would orbit at a distance, similar to where Saturn circles the Sun. To investigate, a team led by Jared Goldberg used the Hubble Space Telescope's ultraviolet spectrograph, aiming to catch glimpses of this hidden partner. They targeted wavelengths that could reveal a faint, hot object, something not visible in regular light due to Betelgeuse's overwhelming glare. Unfortunately, they didn't find a definitive companion. Betelgeuse's brightness and the surrounding dust made it nearly impossible to spot anything directly. But the lack of visual confirmation didn't rule out the possibility. Instead, the mystery deepened. More clues began to suggest something is out there, something unseen, but undeniably influential. One of the biggest puzzles is Betelgeuse's unexpectedly rapid rotation. Red supergiants this old should have slowed down long ago, but Betelgeuse spins at roughly 5 to 15 kilometers per second, far faster than expected. This anomaly might be explained by the gravitational pull of a nearby object. A companion star could be applying tidal forces, much like the Moon affects Earth's tides, helping to maintain Betelgeuse's spin rate. And then there's the regular dimming, that 100-day pulse. If a smaller star is orbiting, its gravitational pull could be stretching and disturbing Betelgeuse's outer layers, triggering predictable changes in brightness and shape. Interestingly, most massive stars are born in binary or multi-star systems. A truly solitary giant would actually be the exception, not the norm. That makes the idea of a companion even more plausible. Some researchers have also considered it may have merged with a smaller star in the past, which would explain its mass and spin characteristics. But that wouldn't explain the ongoing rhythmic changes we see today. The evidence increasingly points toward a current, unseen companion. This companion wouldn't stop Betelgeuse's eventual supernova, but it could shape how the end unfolds, influencing how the star sheds its outer layers, forms dust, and even how it explodes. Betelgeuse is surrounded by intricate clouds of gas and dust, likely the result of massive material ejections. A close orbiting companion might be responsible, disturbing the star's atmosphere, triggering the expulsion of gas and dust that later blocks its light. What might look like a sudden event of stellar material could actually be a gravitational tug, a nudge from a hidden star in orbit. And understanding this could be the key to predicting supernova behavior across the cosmos. If we confirm that Betelgeuse has a companion, it could redefine how we study stellar death. First, it would give us a living example of how red supergiants interact with smaller stars in the late stages of life. These interactions are already thought to drive events like new supernovae and neutron star collisions. But Betelgeuse offers a different kind of system, a volatile dying star influenced by something smaller but still significant. Second, it could transform how we study mass loss in massive stars. Companions could act as triggers for the massive outflows of gas that later influence the type and brightness of the eventual explosion. Third, it could help us build better models for supernova prediction. If we can trace how a companion affects a star's spin, shape, and material envelope, we may gain insight into how long these stars have left before they go supernova, even if it's still thousands of years away. Future missions like the James Webb Space Telescope may finally have the precision and infrared sensitivity needed to cut through the dust and catch a direct image of this hidden companion. Meanwhile, Earth-based observatories will continue tracking Betelgeuse's light curve, monitoring its pulse and checking for spectral shifts. If the 6-year cycle holds, we'll have more chances to test whether something is truly orbiting this mysterious giant. What makes this investigation so powerful is that it's happening in real time, with a star visible to the naked eye. You can walk outside, look up at Orion, and see Betelgeuse blinking back at you, carrying with it the secrets of a long, slow transformation. Whether that transformation is being influenced by a hidden star, a past merger, or something entirely unexpected, we are closer than ever to finding out. Because Betelgeuse isn't just a star nearing the end, it's a cosmic puzzle, and its final act might be more spectacular and more complex than we ever imagined. Thanks for watching. If you enjoyed this journey, leave a like. Subscribe for more cosmic stories and turn on notifications so you don't miss the next mystery waiting in the stars.